Hello my dear friends, I am Shubham from LearnoHub, the free learning platform where you can study physics, chemistry, maths, biology absolutely for free at learnohub.com. So then, let's start. So here in this video, we are at the almost end of the completion of syllabus. We are on the second last chapter, and in the second last chapter also on the third compound in the study of compounds, chapter number 8 of your ICSE chemistry class 10th. Okay, so in this study of compounds chapter, we are now on the compound nitric acid. Okay, we have completed till ammonia, we have seen hydrogen chloride as well. Okay, now the third compound nitric acid, and then here we are going to see the concepts of nitric acid which are strictly there in your syllabus, and after that we are going to see some questions which are asked in your previous year exams. Okay, so without wasting much time, let's start and let's rock. So starting the chapter with the very much interesting question, that is why we should study this compound nitric acid. So let me tell you, there are so many examples, so many applications of nitric acid, but the close ones to us, or the ones which we can see with our eyes and we can just figure out and relate very quickly, are like very popular examples are like for manufacturing dyes which are used for dyeing the cloth fabrics which I have here weared. Okay, so such cloth fabrics are dyed, okay, are colored, and the dyes which are made for coloring the cloth fabrics are manufactured by using nitric acid. Oh, right, seems interesting. Apart from it, it has so many applications, like see, we can use them. It is used in manufacturing of drugs as well. Okay, drugs means medicine. Okay, and also perfumes. Okay, apart from that, yes, the very interesting example or application is we can purify gold by using nitric acid. Okay, right? So you have heard it right. Gold has so many impurities like copper, zinc, and lead, and all those things. So these impurities, okay, dissolve in nitric acid. So if we want to purify our gold and make free from all these impurities, we would just add simply nitric acid in it, and our gold would be purified, right? So interesting applications, interesting examples are waiting. But in order to understand them, in order to use this acid, we need to first study it, right? So I hope you are feeling convinced and you are now ready to learn this chapter. So then let's start. Okay, so not so big chapter, okay, not so big topic, but in recent years in your syllabus there are some topics which have been added. Okay, so I have included all the topics which are there in your syllabus, and we are going to study all the concepts which are given in your syllabus strictly. Okay, so first is preparation, like HCl and ammonia. We have studied their preparation first and then the properties. So here also we are going to do the same. I have divided it into 3 parts. First is preparation. In that we are going to study lab preparation, right? Same like hydrogen chloride and ammonia, we have studied lab preparation for them as well. And then industrial preparation, that is Ostwald process, but not in much detail like we have studied Haber's process for ammonia. We're going to see the glimpse of Ostwald process. Okay, just the equations and the conditions, that's it. And then properties, here very simple properties, its oxidizing properties we are going to deal with in this chapter, and its reaction in that oxidizing properties, its reaction with carbon, sulfur, and copper. That's it. And lastly, the thermal decomposition of nitrates. Now this part, okay, is a pretty like slightly it has some reactions, but it's also quite easy. It has some color reactions. We get colored compounds as well at the end. So you need to remember the observations and all those things in this thermal decomposition of nitrates as well. Okay, so then let's start with the first one. Okay, so starting with the lab preparation of nitric acid, and here we are going to start first with setting up the apparatus. That's the first thing which we do in each lab preparation. Okay, so I have taken the stand, I have taken this, okay, this special glass retort. Okay, special means I'm just calling it special. Okay, this instrument is called as, okay, this apparatus is called as glass retort. Okay, this glass vessel, okay, glass container. And interesting thing is we are going to use this, okay, in the preparation of nitric acid. Also, see here you can observe here the plate is there, and here inside that plate there is sand. Okay, so we are not going to heat directly this glass vessel. We are going to heat the sand first, and then we are going to heat this glass vessel. Okay, and then we are going to make such arrangement that this glass retorts opening, okay, should open up in another flask which is like placed in this slanting position. Okay, so we need a handle. Okay, we need a stand as well as a handle to hold this. But very important thing is all these apparatus. Okay, means this glass retort here. Okay, at any place we are not going to make use of any such material which is made up of rubber or cork. Okay, they are purely going to use everything made up of glass. Okay, in the instruments to prepare nitric acid in this lab preparation. Okay, very important thing. So I will just write it here. This is glass retort. Okay, and yes, we are only going to use glass. Okay, glass apparatus is made up of purely glass, no rubber, no cork. Okay, and now why is this so? See, this question can be asked. Okay, very simple, because the nitric acid which we are going to prepare, it just attacks this rubber and cork. Okay, so we don't want our nitric acid to attack anything else. We want our nitric acid to quietly get prepared, and so that we could use it, right? Simply, so we are just using glass. The apparatus made up of completely of glass. Okay, another interesting thing is here we are going to arrange this flask in this way that the running water should fall on this flask. Okay, now why is this so? I will tell you when we would study the collection part. Okay, so now let's start with the procedure, but before that we need to take reactants, right? From what we are going to prepare our nitric acid. Okay, so very simple, two reactants we have to take. First is concentrated sulfuric acid. Okay, and we have a choice for the second reactant. We can either take sodium nitrate or we can take potassium nitrate, any one of it. Okay, but yes, make sure that both of them, okay, are taken in equal amounts. Okay, now one more interesting thing is here we are going to take this in equal amounts, and we are going to take here this in this glass retort. Okay, and we are going to heat it below 200 degrees Celsius. Okay, we are going to take care of this thing as well. Okay, I will tell you this in precaution as well, but in the process I need to tell you that we are going to take this reactants, we are going to heat it below 200 degrees Celsius, and what would happen then? They would react. Okay, so very simple thing is, now we are going to see the reaction. So in the reaction, now if I am taking sodium nitrate, I would show you, I would write down both the reactions. If I would take sodium nitrate and if I would take potassium nitrate. Okay, so along with concentrated sulfuric acid. So sodium nitrate along with concentrated sulfuric acid. Okay, so what it would give me, I'm heating it below 200 degrees Celsius. Okay, I would simply get, after they react, hydrogen sulfate. Okay, sodium hydrogen sulfate, or we can call it as sodium bisulfate. Wherever it is hydrogen before the sulfate or before the carbonate group, you can call bi also. So sodium bisulfate, and the most important, our nitric acid. Okay, this nitric acid, okay, is getting liberated. Now you can see here, see the nitric, you can see, okay, nitric acid would here get liberated. Okay, now don't worry about these brown fumes. I will tell you about it later on, where we would observe these brown fumes. Means what about all these brown fumes and all those things? You just figure out first here. Okay, don't pay attention to these brown fumes. Okay, I'm just telling whatever thing, you just pay attention to this. So nitric acid fumes start coming out, okay, from this reaction mixture. So now same way you can write the reaction with the potassium nitrate. Okay, so you can pause it here and you can try the products would be all exactly the same. Okay, fine. I hope you would have tried. So I would write it down: potassium nitrate and concentrated sulfuric acid. Okay, I'm taking the reactants. I'm having the condition that it should be heated below 200 degrees Celsius. Okay, and then the products: potassium hydrogen sulfate and nitric acid. Okay, so here nitric acid then moves through this glass tube and then it reaches here in this vessel. Okay, now here what we are going to do is we are going to convert our gaseous nitric acid or nitric acid vapors, okay, to nitric acid liquid, okay, or simply nitric acid, okay, in the liquid form. So what I need to do is I need to condense them. Okay, so for collection purpose I am going to condense the nitric acid vapors. Okay, to liquid. How I'm going to condense it? I'm going to keep this flask below the source of running water. So continuously water would run. Okay, so cool water would fall on this. Okay, chilled water would fall on this. Okay, chilled or like very cold water would fall on this flask, and it would then condense the vapors to the liquid. And you can see here the water, then we can just collect the water down in this trough. So we can again make it cool and again reuse it and all those things. But here, how we are collecting the gas, it's very simple. Okay, nothing much complicated like hydrogen chloride or ammonia. The process is absolutely very simple. But now the interesting thing comes next. Okay, so now we have collected nitric acid in our this receiver or glass flask. But there is problem with this nitric acid. Whatever nitric acid we collect through this lab method, okay, this is slightly yellowish in color. Okay, slightly yellowish. Okay, so now the pure nitric acid is colorless, but now this is slightly yellowish. Now why is this so? Why is it slightly yellowish? See, now the reason behind it, this is here in this nitric acid, okay, there is what has happened is NO2 gas, which is reddish brown in color, okay, has been dissolved, okay, in our nitric acid, and that's why it has turned slightly yellowish. But now we need to figure out the way to make it colorless again. But before that, let's understand from where this nitrogen dioxide gas came. Okay, that's the valid question first. So this nitrogen dioxide came from the nitric acid itself. Okay, some portion of nitric acid, okay, it gets decomposed. Okay, because of the heat, it gets decomposed and it forms this nitrogen dioxide gas, okay, along with water and oxygen. So this is the interesting thing. And because of this, okay, because of this nitrogen dioxide gas which dissolves in the nitric acid, okay, nitric acid turns slightly yellowish. But now we need to figure out the way to make it pure, okay, to make it NO2 free, okay, nitrogen dioxide gas free. So we are having two methods to do this. Okay, very, very interesting methods. First is I will use carbon dioxide or dry air. Okay, so I will write it here. First is carbon dioxide or dry air. Now what I'm going to do is I'm going to pass this carbon dioxide or dry air. Okay, I will collect this nitric acid which I have obtained, and I would place it suppose in a beaker, and then I'm going to pass, okay, very much with enthusiasm the carbon dioxide or dry air through this nitric acid. And what it would do is, here inside the nitric acid there is dissolved NO2, right? I have told you, that's why it's slightly yellowish. So our carbon dioxide or dry air would push out this nitric acid out of this, push out the nitrogen dioxide, sorry, out of the nitric acid. Now this nitrogen dioxide when it comes in contact with air, okay, and oxygen, when it comes in contact with our air, okay, so it gets oxidized, and then once it gets oxidized, it again forms nitric acid. Okay, so we get again nitric acid. So our motive is completed. We have removed the nitrogen dioxide gas, and we are in turn again getting nitric acid. So that's great. So by removing nitrogen dioxide gas, we have removed the yellowish color and we have purified our nitric acid as well. Okay, and we have also got nitric acid at the end. Now, second way is to add excess of water. Okay, now what this would do is, by adding water, okay, what would happen? The nitrogen dioxide gas which is present in this nitric acid, okay, because of which it is yellowish, this would dissolve in water. Okay, this would dissolve in water, and again we would get nitric acid. Now the reaction for this would be exactly the reverse of this. Okay, see, if this would be the reactants, nitrogen dioxide gas would dissolve in water, okay, and there is also the presence of oxygen here, and it would give us, okay, it would give us nitric acid. Okay, the reverse reaction. You just write this as the reactants and this as the product. Okay, no need to write this condition, just the reactants gives product. Forget about the condition for this reaction. Okay, this would be the reaction. Clear? So that's it. How we can remove the slightly yellowish color and why was the slightly yellowish color present in the nitric acid. Now let's quickly see some precautions which we need to take. Okay, so first of all, I have told you the first precaution, okay, at the initial stage only when we are setting up the apparatus, that never to use rubber or cork material, okay, in our apparatus. So that was the first one. Okay, rubber or cork we should not use, only glass. Why? Because our nitric acid attacks rubber or cork, so we cannot use. Second is, okay, we need to keep the temperature, okay, below 200 degrees Celsius. I have also told you this thing. Okay, now why is this so? If we would increase the temperature and we would go beyond 200 degrees Celsius, what would happen is sodium sulfate is formed. Okay, and this sodium sulfate which is formed, okay, it's like hard crust, okay, and it sticks to the wall of this glass retort, okay, here after the reaction. So we are getting sodium hydrogen sulfate, but if we would move on, okay, beyond 200 degrees Celsius, we would get sodium sulfate. Okay, how we would get, I will tell you. Okay, I will show you the reaction first, then you can understand this thing. So if I am taking NaHSO4, okay, which is formed initially when the temperature was less than 200 degrees Celsius, and it is reacting with the sodium nitrate which is present here in the flask, okay, in the glass retort, not in the flask. So what would happen is, see here, Na2SO4, okay, this would form Na2SO4 and then HNO3 would be formed, right? So in this way, so this Na2SO4 would be formed. Other reaction for this is, if we would carry out this reaction directly from initial point itself above 200 degrees Celsius. Okay, so what would happen is, now we are taking NaNO3 and then I am taking sulfuric acid, like concentrated sulfuric acid. Okay, please pay attention, I am not balancing the reactions, you need to balance it on your own. Okay, so NaNO3, sulfuric acid, then, okay, what would happen if I am taking, now this reaction is above 200 degrees Celsius, make sure of, make this clear, okay, in your head, about 200 degrees Celsius. This is also above 200 degrees Celsius, okay. So what would happen? Directly I am starting from the initial point itself by keeping the temperature, by making them react at the temperature above 200 degrees Celsius. So the sodium nitrate and sulfuric acid would react, okay. What they would form? Sodium sulfate they would form and nitric acid. Okay. So in the both these reactions we are getting sodium sulfate, and I have told you what the problem is with the sodium sulfate. It forms hard crust, okay, which sticks to the glass retort and it's very difficult to remove it then. So it's favorable that not to make the temperature go beyond 200 degrees Celsius for us. There are few more reasons that for which we need to pay attention that the temperature doesn't go beyond the 200 degrees Celsius. This was the first one. Okay, another one is the glass apparatus may get damaged. Okay, so that's also a problem to us. Another thing is a fuel may be wasted. Okay, may get wasted. Okay, and one more thing is, if we would increase the temperature beyond 200 degrees Celsius, decomposition of nitric acid would start to take place, and we want nitric acid to get prepared. We don't want nitric acid to decompose. Okay, so that's the very important thing which we don't want, and this would happen if we would go beyond 200 degrees Celsius. So this was the second thing. One more interesting precaution which you need to take is, okay, why we are not using hydrochloric acid. Okay, here we are using concentrated sulfuric acid, right? So you need to take this precaution that never to use hydrochloric acid, right? We have to only use concentrated sulfuric acid. Why is this so? Because our hydrochloric acid is volatile. Okay, and since it is volatile, what would happen when the hydrochloric acid would react with nitric acid? Okay, so when we would start heating it itself, okay, leave about the reaction, when we would start heating it, our hydrochloric acid, since it is volatile, it would just start to get getting converted into vapors. Okay, and it would just move along with the nitric acid. Okay, so nitric acid vapors and hydrochloric acid vapors would be mixed, so we won't get purely nitric acid here. So that would be a great problem to us. So that's why we are not using hydrochloric acid, simply because it is volatile. Okay, we always use concentrated sulfuric acid because it is non-volatile. It won't mix with the vapors of our nitric acid, since it doesn't get converted into its vapors very easily. That's why we say it as non-volatile. That concept you already know, I hope. Okay, we have already studied it as well in acids, bases and salts, and also I have told you in hydrogen chloride as well. Okay, so now till this point we have collected our nitric acid. We have got our nitric acid which we want, okay, from the lab preparation method. But now last thing is to identify that yes, whether that acid is particularly definitely nitric acid or not. Okay, so for that we need to do some tests on it. So I will just tell some 3 tests. Okay, here out of that, first 2 are like quite simple. Okay, third one is quite interesting as well. Okay, second one is also quite interesting. So first one is very simple, we have already studied it. Okay, so concentrated nitric acid, okay, it just decomposes, okay, on heating. Thermal decomposition means, thermal means by heating. Decomposition, you know what is decomposition, it would break down. Okay, so when we would heat, it would break down. That is called as thermal decomposition. Okay, simply into this NO2 gas, water and oxygen. Okay, now this NO2 gas would be liberated, and I have already told you the color of this NO2 gas is reddish brown, right? So the identification test you can write is, by taking the concentrated nitric acid and heating it, we can observe reddish brown gas is getting evolved. Okay, so this was the first very simple test. Another one is, we can add copper, okay, into concentrated nitric acid. So let's see, okay, how the reaction proceeds. So when I'm adding copper, okay, in this concentrated nitric acid, okay, now I would get copper nitrate, okay, this CuNO3 twice, in which copper is in +2 charge. Along with it, I would get this again, nitrogen dioxide gas. This is the only thing which you would relate, okay, to this, or the 2 reactions. So I would get nitrogen dioxide gas, okay, and free, if with free I would get water. Okay, so copper nitrate, NO2 and H2O. Now here again we would observe, by adding copper to the concentrated nitric acid, what we would observe is reddish brown gas is getting liberated. The same thing. Clear with this point? Okay, now the third interesting test which we can perform, okay, to make sure that yes, this is nitric acid or not, is the brown ring test. Okay, so very much interesting test is this one. What we need to do is, I'm telling you the procedure. Okay, so first step is, we need first of all aqueous solution of nitric acid. Okay, and in this aqueous solution of nitric acid, what I'm going to do is, I'm going to add, okay, freshly prepared FeSO4 solution, okay, ferrous sulfate solution. Once I add this, okay, in a test tube, suppose like this. Okay, now what I'm going to do next is, I'm going to slowly add concentrated sulfuric acid. Okay, very slowly I'm going to add. How I'm going to add? In this way, that it just slides over the side of the test tube. Okay, like this. I'm not going to add drop wise. Okay, drop wise addition is not right addition, right type of addition. Okay, I would add concentrated nitric acid slowly, that it would slide through the test tube. Okay, and the slowly addition would continue on. Okay, further what I'm going to do is, I'm going to then cool the test tube. Okay, so after cooling, what I would observe is very interesting phenomena. Okay, I would observe a brown ring, okay, like this. Okay, right? Like this I would observe. I would see two layers of liquid, okay, two layers, this and this, and in between these two layers I would observe this brown ring is formed, okay, which is at the junction of these two liquids. Now this one is concentrated sulfuric acid, okay, because since it is heavier, okay, sulfuric H2SO4, sorry, okay, so since it is heavier, what it would do is it would just settle down, okay, and the rest addition which we have done is this aqueous solution of nitric acid and freshly prepared FeSO4 solution. This would be above, okay, above the ring. What this thing? Now after observation of this brown ring, you need to understand one more thing. You need to remember this thing, that be very careful, do not disturb the test tube, okay. If you would disturb the test tube, the ring will disappear, okay. So this was all about the observation. Now let's move on to what actually happened here, okay. Let's see the reaction, how this brown ring is formed, okay. So for that, see, what we did is we need to just recall. We added, okay, in the aqueous solution of nitric acid, FeSO4 solution, freshly prepared FeSO4 solution, correct. Now in this, okay, I have also added concentrated sulfuric acid later on, okay, in the second step. So what would happen is this ferric, here it is ferrous sulfate, okay, but in the product we would get ferric sulfate. Now let's write the formula, okay. Ferric is 3+, okay, so 3 2s are 6, okay. I would just show you here, Fe3 plus SO4 2 minus, right? So I need to balance them, so 2 3s are 6 plus, 3 2s are 6 minus, okay. So Fe2 SO4 thrice, this would be the formula. So this is the ferric sulfate which would be formed. Along with this, I would get nitric oxide. We have studied about this in the previous chapter, okay. You can also call nitrogen monoxide to this, and free is water to us, okay. Freely we are getting some water as well, okay, after the reaction. So I would just write here nitric oxide, because this nitric oxide formation is very important. This nitric oxide would then again react with our ferrous sulfate, okay. That's why our ferrous sulfate is also very important, okay. Our ferrous sulfate is actually helping along with nitric acid and sulfuric acid to form this nitric oxide. This nitric oxide in turn, when it is formed, it would again react with the ferrous sulfate and it would form this compound, okay, nitroso-ferrous sulfate, okay, this one, FeSO4.NO, whose name is nitroso-ferrous sulfate, and this compound is brown in color, okay. So this is the brown compound which is formed between the two liquids, at the junction of the two liquids, okay, between them. Now one more interesting thing, the last thing about the brown ring test is, why do we use this freshly prepared FeSO4? Why freshly prepared? Okay, this is because if we would keep our FeSO4 solution, okay, after preparing it, if you would keep it open, okay, so it would get oxidized, okay. If we would expose it to atmosphere, okay, this FeSO4 would get oxidized to ferric sulfate, okay, just we have seen here in the product, ferric sulfate, okay, and our ferric sulfate will not give us the brown ring test, okay. So we need to make sure that our ferrous sulfate is alive, okay, it is not dead by becoming ferric sulfate. So in order to keep this alive, okay, we know that it would get dead if we would keep it open in the atmosphere. So what we do is, once it is prepared, we don't keep it open in the atmosphere because it would die. So that's why what we do is, okay, or it would simply not exist, okay. I'm just joking. So in order to make this ferrous sulfate, okay, remain as it is, okay, before getting converted into ferric sulfate, only we use it quickly in this brown ring test, so that we could avoid the conversion of this ferrous sulfate into ferric sulfate, and thus we would have our ferrous sulfate intact, so we could use it for brown ring test and we would get the brown ring test. Okay, clear with this point? Now moving to the second method of preparation of our nitric acid. That is the industrial method of preparation, which is Ostwald's process. Okay, so in our syllabus, it's clearly stated that we don't need to go into much detail in this Ostwald process. We have to just study the equations along with the conditions, okay, for the formation of nitric acid through this process. So still, I would tell you simple 3 steps. Okay, in order to understand the equation itself, we should know those 3 simple steps which are taking place in this Ostwald process for the preparation of nitric acid. And first one is simply catalytic oxidation of ammonia. This thing we have already studied, right? In the ammonia chapter, we have seen how ammonia is catalytically oxidized. Okay, so the exactly same reaction, okay, same equation, same condition would be here also there. So here we are using catalyst platinum at 800 degrees Celsius to, okay, platinum catalyst at 800 degrees Celsius to oxidize. See, in this way I am remembering the reaction. Oxidize whom? Ammonia. Okay, and then what I get is, we have already studied nitric oxide, water, and along with it, this reaction is exothermic, so heat would be released. This is the simple reaction, okay, for the first step. Okay, so you need to balance it on your own. That's the very basic condition which you know now. I don't balance the equations because it's quite easy, and now you would be pro in balancing the equations, right? So yes, next one is, now once we get nitric oxide here, okay, now what we carry out is oxidation of this nitric oxide. Okay, and so since it is oxidation, we need oxygen. So with the nitric oxide, oxygen would react, and here only 50 degrees Celsius temperature is fine, no need of this 800 degrees Celsius temperature, and it would get converted into NO2. Okay, now further what we are going to do is simply we are going to use this NO2 and prepare our nitric acid. And how we are going to make this NO2 get dissolved in water. Okay, so absorption of NO2 in water to get nitric acid. So this reaction we have already seen. Okay, NO2 plus H2O, and here we would also need oxygen as well. Okay, so the reverse reaction for the thermal decomposition of HNO3 is the reaction for this step. Okay, so reverse means ulta, so that's why reactants, okay, would be the product, products would be the reactants, right? So products were NO2, H2O and O2, so these are the reactants, and then I would get HNO3. This is the reactant. In the thermal decomposition, it would become product. Okay, so NO2 would combine with water. Okay, it would get absorbed in water along with oxygen. Okay, and we would get our nitric acid. Now we are done with the preparation. Now let's see the chemical properties. So first here we are going to deal only with the oxidizing properties of nitric acid, and in that only we are going to study 3 reactions. First is, okay, with carbon, second is with sulfur, and third is with copper. Okay, these are non-metals. We all know the reaction with non-metals and the reaction with the metal, which is copper just. So with carbon, okay, our concentrated nitric acid, okay, reacts, and now see, you can see an oxidizing property. Now it would what it would do? Oxidize carbon. So what would be the oxidized form of carbon? Carbon dioxide. You can remember in this way. Oxidation. Carbon undergoes oxidation, means addition of oxygen, means carbon dioxide is getting formed simply. And along with carbon dioxide, now what would be formed is NO2 and H2O. Very simple. Okay, so this carbon has got oxygen. Now what is remaining? Hydrogen, nitrogen and oxygen. So NO2 and H2O. All the 3 elements are involved in formation of NO2 and H2O. That's it. Same with sulfur. Now here, if you would apply the same logic and you would write the reaction, okay, which you can try on your own, but you may get like wrong, because here sulfur reacts with concentrated nitric acid, but it doesn't form SO2, it forms H2SO4, sulfuric acid. Okay, sulfur gets oxidized to sulfuric acid, and here along with the sulfuric acid, NO2 and H2O, same NO2 and H2O is formed. Okay, so this is the simple reaction with carbon and with sulfur of concentrated nitric acid. Now here with the copper, we are having 2 reactions. Now very often students feel very confused with this reaction because they don't clearly understand how the reaction is taking place, I will explain you with the copper what is the problem. Okay, so here with the copper, okay, the first one is copper plus we are having dilute nitric acid. You suppose in this way we are having dilute nitric acid and it is very normal, cold. Okay, we haven't heated it, it is cold. So when we are using this cold dilute nitric acid, what would happen is our copper would get converted into nitrate, the metal gets converted into metal nitrate. So copper gets converted into this CuNO3 twice. Okay, nitrate in which copper is having 2+. You remember this thing. Okay, but after conversion of metal to the metal nitrate, what would form when dilute nitric acid is there, okay, and cold? You just don't forget this. When the dilute nitric acid is used and cold dilute nitric acid, so at that time nitric oxide would be formed. Okay, nitric oxide, and the another thing is water, simply. Okay, copper nitrate, HNO3, copper nitrate, nitric oxide and H2O. Okay, so this would be the products here. So here nitric oxide would, forget about the liberation and all those things, nitric oxide would be formed. That's it, no need to go into much details. The second one is when the copper is treated with, now here it was dilute nitric acid but cold one. Now I would just change it. I am taking dilute nitric acid, but now I am taking hot dilute nitric acid. Okay, simply. Now when hot dilute nitric acid is taken, okay, the product which is formed is exactly the same, okay, in terms of this nitrate. Copper nitrate itself is formed. The change you should remember only is about the nitrogen oxide. Which nitrogen oxide would be formed? Okay, so here it is nitrogen monoxide, nitric oxide. Here, okay, since we are taking hot, it would give us nitrogen dioxide. Okay, and nitrogen dioxide, we know what's its color? Reddish brown. So you need to remember this thing. Okay, the observation for this reaction, reddish brown color gas would be evolved. Okay, yes, so this is same. In place of nitric oxide, only nitrogen dioxide would be formed, and yes, rest water is exactly the same. So this is the reaction. Now the reaction for this dilute nitric acid, but when it is hot, okay, this is the reaction, right? So same reaction is for the concentrated nitric acid. So if at all in the exam they ask you the reaction with concentrated nitric acid, you just need to remember the reaction with the dilute nitric acid, which is a hot, this one. Okay, and quickly in your brain it should be clicked that, oh, hot dilute nitric acid means NO2. That's it. So rest products are same, copper nitrate and water. Very simple, very simple. Okay, now let's see the last topic of this chapter, which is thermal decomposition of nitrates. Now the last topic itself, it's like quite slightly lengthy because it has some reactions. That's it, and very simple reactions, don't worry. So first we are going to see the thermal decomposition of alkali metal nitrates. Okay, simply, so understand this thing, alkali metal nitrates, okay, when we heat them, they form a colorless liquid. Okay, and this colorless liquid, when we further heat this colorless liquid, okay, so we get nitrite, okay, alkali metal nitrites, and oxygen gas. So this is the general simple reaction. So what we need to write is simply, see, I would just write alkali metal nitrite. So I would take NaNO3 or KNO3. Then the simple condition is to heat it, right? Because condition is just heating, because thermal decomposition, right? So we are heating it, okay, and then it is getting decomposed. It is getting it is breaking down into this nitrate. It is breaking down into nitrite, NaNO2 plus O2. Okay, and this KNO3 would be broken down into KNO2 plus O2, right? Alkali metal nitrite, okay, plus oxygen, alkali metal nitrite plus oxygen. Now here the interesting thing is, okay, this oxygen, okay, when it is liberated from this molten liquid or this colorless liquid, okay, if I would keep a burning splint, okay, or I would take a burning splint, okay, and bring it near this molten liquid. Now what is happening? This molten liquid is decomposing into nitrites and oxygen. So oxygen is getting liberated. So when I would place, okay, the burning splint, okay, near this molten liquid, which is getting decomposed, Okay, so oxygen is getting released here, and this oxygen would in turn make this burning splint to burn vigorously. Okay, right? So this is the reaction. This is all about the reaction. Okay, how it is actually formed, means how the process is taking place. Okay, and in this process, how the O2 is the O2 formed is how it can be detected by taking the burning splint. Okay, so you can just detect that yes, oxygen is really getting liberated. Okay, and the lastly, you would have this. You can just remember that this NaNO3 is slightly deliquescent. Sorry, QUESCENT, and KNO3 is CC, colorless crystalline. Okay, very well done. Now, moving ahead to the next type of nitrates. Here you can see calcium, zinc, lead, copper. Okay, so I'm taking this calcium nitrate. Okay, all these elements are in their +2 charge. Okay, in the nitrates. So calcium 2 plus NO3, then would be required how much? Right? See here, calcium 2 plus, then NO3 is -1, so it would require 2 NO3 minus. Okay, so CaNO3 twice, right? Simply CaNO3 twice. Now in the same way, you can just figure out the formula for other nitrates. Zinc nitrate is also same. Zinc is in 2 plus, so it would require 2 NO3. So ZnNO3 ZnNO3 twice. Okay, PbNO3 twice, CuNO3 twice. Okay, so calcium, zinc, lead, copper. Calcium, zinc, lead, copper. Right? Now what we are going to do is we are going to heat them so they would decompose. Right? This is what we call thermal decomposition. And what would happen? Okay, these nitrates, when they would decompose, they would simply form oxides. Okay, metal oxides, and yes, this gas, NO2 gas, is getting liberated, which is a very important observation for all these reactions. Okay, all the decomposition, okay, reactions here on this screen for calcium, zinc, lead, and copper. Okay, it would give you NO2 gas. Okay, which can be observed because it is reddish brown in color. Right? Don't forget about the color of this NO2 gas. Very, very important. Very, very frequently used. Okay, so it would give us metal oxides and NO2 and O2. Okay. Now I would just write the reactions here. Okay, so metal oxide here, calcium oxide would be formed, NO2O2. Okay, then zinc oxide, NO2O2. Okay, and same way lead oxide, PbO. Okay, ZnOCaO, NO2O2, and then CuO, NO2O2. Okay, so you would see that, oh, these are very simple reactions, but now you need to remember some more things as well. Okay, I have told you a common observation, that is, in all these reactions you would observe reddish brown gas is getting evolved. Okay, NO2, 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 right? But along with it, there are some other observations as well for this reaction. Okay, calcium nitrates decomposition, you would get calcium oxide, and this calcium oxide is white in color. Okay, so on whiteboard I cannot use white, so I'm writing with black. Okay, click it in your brain that calcium oxide is white in color. Okay, same with zinc oxide. Now there is an interesting story with the zinc oxide here. Okay, when it is hot, it is yellow. Okay, when it is hot. Okay, for writing hot I would write with red. Okay, so red would denote hotness very much clearly. And when it is cold, okay, it is white. Okay, when it is cold. So this is also an observation which you can write if asked in your exams. Okay, lead oxide is again yellow. Okay, yellow substance would be formed, and copper oxide, yes, it's black. We have already studied this copper oxide. Okay, Cu2, copper 2 oxide. The passage of ammonia gas over the copper 2 oxide, it gives us copper, reddish brown substance, right? We have seen in ammonia. Okay, so just try to correlate the reactions in this way, correlate the concepts in this way, because maybe in exams also they may ask you the concepts, okay, which are related to each other from the different chapters as well. Okay, so you should be prepared. Mostly they don't ask in this way, but still you should be prepared. Okay, so these are the reactions. These are all about the reactions for this nitrates. Now let's see the decomposition of silver and mercury nitrates. Okay, so these two nitrates are very cool enough. Okay, once they decompose, okay, when we are heating them, they would simply give us metal. Okay, and same like the previous nitrates, they would give us NO2 and O2. Sorry, NO2 and O2. Okay, so now you just need to write the reaction, and it's very simple. So I'm taking silver nitrate AgNO3. This is the AgNO3. Ag is in +1 charge and Hg is in +2. That's why it would be HgNO3 twice. Okay, and then I would heat them. What I would get is silver, mercury, and then NO2 and O2. Same way, NO2 and O2. So you just need to remember the general reaction, and then writing the reaction becomes easy for you. Okay, here also the common observation would be, you would observe reddish brown gas is getting liberated. Okay, but along with it, okay, for silver, the color is, okay, silver, you would observe when the decomposition of silver nitrate is taking place, you would observe silver gray substance is getting formed, okay, which is actually silver. Okay, but you would see that silver gray substance is getting formed. And when mercury is getting formed, okay, when the decomposition of mercury nitrate is taking place, okay, so you would observe silver mirror substance. Okay, very interesting. Now the last nitrate which we are going to see, that is the ammonium nitrates decomposition. Now try to recollect, I have told you when we were starting to study the ammonia, okay, in the first slide itself, why study ammonia, I have told you that ammonia is used for preparation of explosives like ammonium nitrate, and here you could see the explosive decomposition of ammonium nitrate. Okay, so it decomposes, right, explosively. How it decomposes explosively? Let's try to understand this thing. So ammonium nitrate, NH4NO3, this is the formula. Okay, the explosive decomposition in such a way that it left no residue itself. Okay, you won't find any residue remaining back, because whatever is forming, it is in the form of gas. Okay, so what you would get is N2O, nitrous oxide. Okay, and you would get H2O, water vapor. Okay, so no residue left. And interesting thing is, nitrous oxide is called as laughing gas. Okay, so see the nature's beautiful creation, that the compound, okay, which is explosively decomposing is giving up a gas which can make people laugh. Okay, how rare contradiction is it, right? So this is science. Now moving ahead with the questions. So we would see questions in the next slide. So very simple one. Okay, just now we have observed. So questions, you can observe the year in which they are asked is here. Okay, so state one observation, lead nitrate is heated strongly in a test tube. So lead nitrate is heated means we are trying to do its thermal decomposition. So lead nitrate, when it thermally decomposes, we know what it gives. It gives us lead oxide. Okay, because lead nitrate we have studied, it gives us lead oxide, NO2 gas is given out and oxygen is given out. So you can write the one observation which is very simple, is reddish brown gas is liberated. Or if you could remember in your exam, that's well and good, that this lead oxide is yellow colored, right? So you can write yellow residue or yellow substance is formed. Like these two observations, you can write it down. Okay, moving ahead. So state one relevant observation, action of concentrated nitric acid. Okay, concentrated nitric acid on whom? On copper. Okay, so now we have studied this, that if hot dilute nitric acid or concentrated nitric acid, okay, is used, we get copper nitrate. Okay, and the another product is water, which is same for hot dilute nitric acid and cold dilute nitric acid. Okay, copper nitrate and water. But the thing which is getting differed is the nitrogen oxide, which nitrogen oxide would form, and that's the key for this answer. If you would remember that nitric oxide, see how they make the question paper. Okay, they know that if you know the reaction, then only you could tell the observation. So the copper nitrate and water would be the same products, but here if you are using concentrated nitric acid or hot dilute nitric acid, okay, NO2 gas is getting liberated. Okay, and this NO2 gas is reddish brown. So your observation would be reddish brown gas is liberated, and you will get full marks. Okay, now let's see the next one, the last question. Write a balanced chemical equation. Okay, reaction of carbon powder and concentrated nitric acid. Okay, so see, we know this carbon is non-metal, right? And our nitric acid oxidizing properties we have studied. So it oxidizes the carbon to carbon dioxide, okay, and rest is NO2 and H2O. That's it. So this is the reaction. Now you need to balance this reaction. So it's very simple, Sikka. You can balance it on your own as well. Okay. So with this, we have reached the end of this chapter. Okay, nitric acid. So I hope you would have enjoyed learning with me. You would have understood all the concepts of this nitric acid. Okay, but please do let me know this thing in the comment section. Okay, I would be waiting for your comments. And as you all know, LearnoHub matlab free hai par best hai. So stay tuned, keep studying. We will meet in the next video with the next compound, sulfuric acid of this chapter. Till then, bye bye and have a great day.